fMRI is such a useful tool to map the brain function. Baldev alluded to the silent fMRI in the first talk. So we had the 3D radial-based zero-T acquisition, the silent anatomical imaging in our portfolio for a while. And then our scientists had this light bulb moment. You know, fMRI is loud, EPI has distortion and signal dropout at 7T. So why not add a T2 preparation to the 3D radial zero-T acquisition and have a low distortion, minimal signal dropout fMRI scan, which leverages the high sensitivity at 7T and has 3D isotropic brain coverage. It's like a match made in heaven. So let's look at the images. So here I'm showing a relative to a 1 millimeter isotropic MP range. You can see here that the gradient echo EPI fMRI has a lot of distortions as we typically see, but the 3D silent fMRI is minimally distorted, and you can imagine that this would be ideal for looking at cortical activations. Again, in this case, proof of the pudding is in the hearing. So let's listen to ambient noise. This is just the chiller pump going on in the background in the scan room when there's no scans happening. This is the gradient echo EPI fMRI that we are used to. And this is silent. These are some comparisons between gradient echo EPI, spin echo EPI, and 3D silent for task experiment. And you can see here that both the spin echo EPI and the 3D silent, they have the same sensitivity, but the 3D silent is, first of all, it's silent, and it has a whole brain coverage. Now, you can imagine that having a noise-free environment can be a real enabler for true resting state fMRI and for doing auditory and word processing tasks. Now, on the 3T, we don't have this high sensitivity of the 7T, so our scientists did a slight adjustment to the sequence so that it would still be silent but have T2 star rating. And this is a collaboration with King's College London, where they have demonstrated looping star fMRI, which is what they call this for the 3T version. They have demonstrated this for a variety of block and event-related paradigms, and for speech processing studies in the silent environment that can be provided by looping star. Active regions were revealed that are not detected with GRE-EPI fMRI. This is a poster that is in this year's OHBM, so please visit if you are interested to learn more about the technique. Another direction we are taking with fMRI is multi-echo EPI. It's with our simultaneous multi-slice technique or hyperband to ensure that we can still get the high temporal resolution. So this is showing a plot, the activation plot for fear conditioning in the prefrontal cortex. And you can see that the combined echo, the bottom row, has much more sensitivity than any of the individual echoes. So you get the benefit of the high activation of a late echo without the disadvantage of the signal dropout. There is a poster on this topic in this year's OHBM, which looks at TEDANA, the T-adjusted denoising, using this multi-echo technique. So I hope I could give you a sense of some of